Good evening, everyone. Uh, so I'm Tanmay. I'll be your host for today. And today's topic is a sneak peek into micro front ends. And our speakers for today are Nilesh and Nikesh. So I'll give a brief introduction for both of them and then hand over to them. Nilesh Thorave is a senior consultant at ThoughtWorks with more than 5 years of experience in front-end development using different frameworks like React Native, React, and Angular. While Nikesh Shetty is an application developer with 8+ years of experience in building mobile apps and web applications using AngularJS and React Native. Over to you, Nikesh and Nilesh. You can also mention any points that I missed out.
Yeah, thanks, Tanmay. Thanks for the lovely introduction. Without any more wait, we'll just begin the presentation. So the topic for today is sneak peek into the micro frontends. So I think the term micro frontends, most of us would have heard it, or might have heard it in the backend world as microservices, right? So micro frontend is similar to what you have as microservice in the backend, but more for the front end side of the things. Just a quick check. You folks are able to hear me well? Or should I raise my voice or lower it? How is it?
It's fine.
Yeah, Nikesh.
Perfect.
Just one more thing, Nikesh and Nilesh. Do you want questions during the presentation, or should they be just dropped in the chat?
I think we can make it free flowing. Since we have roughly 60 participants, right? I think for the betterment for everyone, we'll take it in the middle itself. So Nilesh is watching the chats. Just ping over there. We'll stop over there and answer the questions.
Sure. So everyone,
I don't want to. Yeah.
You can drop your questions in the chat, and Nilesh will answer them. And please keep yourself on mute at all times. Thank you. Everyone except the speaker. Yes, Nikesh, you can go ahead.
Yeah. Cool then. So moving forward, right? So let me give a little bit of background of where I'm working on what is the scale that we folks are working on, right? And where this idea of exploring this micro frontends came in. So one second. Yeah. So why micro frontend, right? So for at least for my project where I've been working for more than a year, right? In terms of just statistics, if I have to say, right, we roughly have 50 to 60 commits on an average on only the web repository for the front end app, from the front end side of things. And then on the very good day for the business and a very bad day for the developers, the commits go still 132 or 140. So that's in a day. So that's a scale that we both are working on the project right now. And typically, like to answer, right, why this micro front end, right? Like usually we start with the what part, but we just made sure that we start this time with the why part, right? Why exactly the micro front end thing comes into picture, right? So for any, like this is the author of the micro front end itself, like Cam Jackson, who was the thought worker, like he coined this term in 2016. So so front end development with JavaScript, CSS looks pretty simple for your POC or for your mini project. Okay, so till that point of time, it's pretty simple, right? But a good front end development, right, is really hard, and even more challenging is scaling this front end development, right? When you have like 10 to 12 teams joining your project, right, working on different modules. So that's when the real challenge comes in. And this definition perfectly fits in, and that's where the idea of micro front end comes in. So now that we know that why the part of the micro front end, right? Why the idea of micro front end comes in, like for which kind of sizes? Basically, you'll hear micro front-end terms most of the times when your when your team size increases. There are conflicting changes between your teams, right? So these are the areas where usually you pitch in the micro front-end topic. So nutshell, the definition of a micro front-end is basically, you have a independently deliverable front-end application. So for example, you'll have let's take a simple example, right? You have some shopping cart example, right? There are different modules to it, right? There would be a team which works on the login part of things, right? Which has more experience in storing your auth tokens or authenticating the user, right? So you have the front end, you have the team which works on this login part. Then you have team which works on the data side of things, which is making sure whatever you think you see on the shopping cart, right? All those images are loaded, etc. So what essentially here we try to delve here is each team, right? Whether the team which is working on the login module or whether the team which is working on your shopping cart loading of images, right? They should have the choice of independently building their modules, okay? Be it the tech stack, be it the delivery, or be it the ease. So, we are basically, look, the way we divided them into teams, right? The same way we are actually segregating or, bringing the, what do you call, separations over here. Like a login module would be separate from rest of the application. Cart module would be separate from your application. So that is what the idea of a micro front-end is. I'll take a very simple example, right? Coming back from the same example, right? The login module, right? People choose React.js, right? Because they found it efficient, or they found a very good library which does the lot of login related things. Then they chose for the cart, they chose Vue.js. And for the third component, which maybe tomorrow they would be building, they plan to choose AngularJS, because let's say React and Vue.js is getting obsolete. It's not though, but just taking an example. So you'll have a typical source code, right? Like each one of them would have its own repository, and then you will have the build and test pipeline where you will every check-in or every code commits would be build and test, and then thirdly they would be launched into production. Okay, this is an independent workflow. Okay, now this is, you might be thinking, right? Like this is something that would be already be there, right? Like each team working separately, right? So, and launching that things to production. Where micro frontend really comes into here is where you actually seamlessly, like as a customer, right? I should not identify that, okay, there is a login team, there is a shopping cart team. Okay, so the part which comes in the micro frontend is this combination where all the three apps are combined into a single application. And as a customer or as a user, right, he should not be able to discriminate. Okay, this came from this part, okay, and the green part came from Vue.js. So that tight knitting of things at the end is what a micro frontend is. So talking about the key benefits, right, where it really hits well for you. So first is the way I started with, right, like the micro frontend, the thought of micro frontend really comes to people who have a very large code basis, right? And the reason that they are having problem is because they don't want to get lost in the larger code bases, right? And for example, if you have to change any constant or any small change, right, which spans across so many files, login, cart, etc., right? It's a thing that you want to avoid. So micro frontend helps you in getting your smaller code bases, right? Each repo handling only a specific part. Second is better scalability, right? So literally this is a faster thing. So I think a lot of you folks, right, who are working on the front end application, how many of you folks have really felt the pain of running the test? Not running individual tests, right? But if you have to push your code into repo, right? You'll have to make sure you'll have to run the test, right? Imagine a 4 lakh code base, right? The number of tests that a 4 lakh code bases would be having. the permutation and combination, right? Imagine the time that that needs to be taken while running this test, right? So, one thing that comes out of the box here is, better scalability, faster and independent deployments. Like you can deploy at your pace, right? You don't need to wait for like 70 odd tests to be running, right? You can just focus on your 10 tests, push it, and get free. Of course, easy upgrade, right? Like for example, you found a vulnerability in your login module, right? A lot of time happens is your if in a usual monolith application, right? You'll actually have to make sure that, okay, let's make sure that the other's code is actually in a good state, right? That's like if there is a vulnerability, you need to make sure that all the other teams are taken into consideration. Plus, you'll also need to make sure that I'll need to take an approval from the other teams, right? So here it's just the login module. I just need to make sure that my module is backward compatible with the other modules, and I'll release it to production. That's it. I just care for my module. And of course, like when I release it to my module, I need to make sure that all my previous integration on older version is working fine. And as showed in the previous diagram, right? You really have the choice of using React, Vue.js, AngularJS, like your choice. For example, tomorrow you decided, okay, I want to do a small POC and release it to production, but I'm not sure about the Vue.js. I don't have the required skill set or people working on AngularJS, right? It's okay. Bring in your new tech stack, build your micro frontend and launch it, right? There is no dependency on any particular framework or learning curve or any framework. Last, the next is so if you see this diagram, right? So you have 3 individual components over here: orange, green, and purple, right? So one of your team owns the first one, team B owns the second, and the third one is owned by team C. Okay. Now, usually what happens in a few areas is like, it depends on organization to organization. You might have teams which deal only with the styling. Okay. So let's say they will say that, okay, we'll create a separate team that deals only with the styling aspects. So with micro frontend, this approach to completely goes off. You'll have to train your people so that, vertical alignment happens. Your team needs to know, like, for example, the team A, which owns micro frontend, needs to know the stylings. He needs to be good in CSS, forms, and validation. So this is actually a good design, good design in terms of architecture, because horizontal teams usually don't scale well. For example, in one of the initial times, you can, when the project starts, you'll have few folks working on styling, which is perfectly fine. But as the team grows, right, or as you start having a lot of functionalities, you can't just say that, okay, CSS is just owned by few people. So that is kind of an anti-pattern, and it hits a lot. Like I had some few personal examples from older projects where people had just one team for this styling, and during the peak times, right, when the business had a lot of functionalities to go live, right, this entire only single team, right, was the bottleneck. So there were dependencies for other spots saying that we couldn't get the things done because the styling team was not there, or styling team doesn't have bandwidth. So so micro frontend makes you to think in the vertical fashion actually. And who knows better than this? Like, you folks might have joined a new project, right? I'll give you 2 options, right? Either work on a module, okay, module A, which deals with the shopping cart or login, or work on a project which has all of these things combined, and find your way. What would you choose? You like to have a smaller code base where you can, where you can navigate it easily, right? So I think this is one of the key advantage of you moving to the micro frontend. So that's about why this micro frontend and how it benefits you. Now, if you think that this is something that really helps you, or this is advantageous, handing over to Nilesh, who will apply it or go through the implementation of this. Thank you.
Yeah.
Right.
Thanks, Nikesh. So now that we know the all goods of micro front ends, let's see what are the different implementation approaches that we have in micro front end. So first one is build time integration, where you compile, build, and compose application and then publish to the server, which will eventually serve to the client. Second one is server side template composition, where you compose your application at the server side and then serve it to the client. Third one is runtime integration, where your composition of application happens at the client side. So that's basically a brief of the different approaches. We will see those in brief. Before that, let's discuss that example that Nikesh showed, so that we can try to relate that example in our future slides. So first micro frontend that I can imagine in that application is a dashboard where we can show different products, and user can just navigate through different products and add them to the cart. Then second one, I can imagine of a cart where my selected products will be there. I can order them and I can get those delivered to me. Then third one, which can be kind of important, will be a login part. So where I can just log into the application and all the authentication stuff can be handled in that level. Now, this is basically a different micro frontends. We need to combine them into one application that will be your main shopping cart application. Yeah. So this will be your main application at the end. Now, let's go through the different implementation approaches. So in build time integration, first you build or write your code, then it gets compiled and built into a single place. So maybe it may be a server. So all the micro frontends will be compiled and placed into your server. And whenever a client makes any request, the appropriate build will be served. So a point here to note is everything is pre-compiled. So whenever you release any one micro frontend, you have to compile all the micro frontends and then it will be deployed on the server. So that is build time integration. You can refer the code or package.json, sample package.json. So we will have a dependency on different micro frontends like dashboard micro frontend, cart micro frontend, login micro frontend, and our main application will be a shopping cart micro frontend. So this is a build time integration in a nutshell. So there are different ways to do this. One way we can simply do is publish any micro frontend as a package. So there are different package managers like npm yarn. We can publish it as a different packages and then consume it. And there are other tools as well that can help, like Lerna. Lerna is a good tool that helps you to refer to different packages in the same repository. So yeah, those are the implementation details for build time integration. Now let's go to the server-side template composition. Here, your micro frontends are composed into one application at the server side. So we can imagine a service which is sitting in between your client application or a client that means a browser and your actual application server. So that intermediate service basically calls your different micro frontends, compose that application and serves it to the browser. So here you can see including file that contains include tag, which basically tells this page needs file.html to be rendered before. So the intermediate service just fetches that file.html, composes that application and serves it to the browser. Now, point here to note is the page is completely assembled at the server side. What you send it to the client is a simple HTML or CSS. So you don't have to do any extra composition at the client side. Now, next thing is a runtime integration. Yeah, so this is most of the people would like to go for this runtime integration. This is a complex thing to do, but yeah, people should like to go for this only. So here, your application which is inside your browser decides which micro frontend to call. So let's say our shopping cart application, right? Whenever a user sends a request to the shopping cart application, a main application that we had is like container application that will be served to the browser. Then it will decide which macro frontend to call based on different user. Let's say user clicks on the cart, so it will call the cart wala macro frontend and it will just render it. Then similarly for other macro frontends as well. So there are different ways to achieve it. First one is using iframe that we have been using in many things. Like we have been using it for Google Maps, for Bay reports. We have been using iframe for a very long time. So we know how the iframe works, what are the pros and cons of iframe. But yeah, that is again a way to implement micro frontend. Then second one is integration via JavaScript. So we can have JavaScript included in your files and when in the index.html, and that can at the runtime decide which micro frontend to call and fetch the relevant components. Then third one is a web component. This is a new thing. So web component is a suite of technology that allows you to build reusable components. So you have to follow the contract related to web component. So all the browsers are not currently supporting web component, I think. So the browsers are getting compatible, but those are not completely supported yet. Now, let's see all these three in a one glance, and let's try to compare it. So if you see, we have three different columns for different approaches, three different approaches. Then we have divided it into four phases. First one is a repository. I should not call it a first. You can say go from top to bottom or bottom to top. That's completely a perspective. But I would rather go from bottom to top. So repository phase will contain every micro frontend will have a different repository for themselves. So and that is applicable for all the three approaches. While in the build time integration, the code is built and compiled and deployed into one application in this phase. Build or deploy phase basically. For the server side integration, whenever a client sends a request, it goes to the intermediate server that fetches different micro frontend and composes it and again renders to the client. While in the runtime, everything is handled at the client side. You don't need to worry about it, like client decides which micro frontend to call. Now we have seen the runtime. Let's see some let's see some frameworks which are popular for implementing runtime integration. So Webpack 5 and Module Federation, all of us know the Webpack. We use it for bundling different applications in Angular, React, in application. So Module Federation is a plugin introduced in Webpack 5, which basically allows you to import JavaScript dynamically. And that can help us to implement micro frontend. Then second one is a single SPA. This is a framework completely built for developing micro frontends. So it has its own CLI. You need to use that CLI to generate different components and different micro frontends. Similar is a Print.js. So these are only few frameworks which are popular. There are a lot many frameworks there, and we can refer to them. Now we have seen the different implementation approaches. Let's see it through an example code. We'll go through the sample code and try to understand how it is implemented. I'll go for Webpack and Module Federation, and we'll see the example. I will need to share the screen. Nikesh, can you stop the sharing? Yeah. I'll just share my
there are
desktop.
some interesting questions. Yeah, maybe we can just take a couple of them while you are setting up.
Okay.
So I guess Vishal has asked, in the runtime integration, should we still not rely on the container app to combine all the micro frontend entities?
Yeah, I think yes, we will need some kind of a main application which will combine the other micro frontend, right? So who will decide which micro frontend to call in that case? That's why we need a container kind of an application, which will basically include it at runtime. And that is, I feel, is more way to go. There can be other way, like you can call other micro front ends, like maybe you can directly call Cartola micro front end, and that will decide I need a login to call, and it can go to login as well. But that eventually might become difficult to handle, and there could be scenarios like passing the data and all those things might be difficult. So having a container application gives you more control, how your flow will work and how you can pass the data and all. So yeah, it's I think having container application is a good thing for that. Yeah, what else is there? How should handle central session management and do central authentication for multiple macro front-end integration? Okay.
I'll just read out the question for everyone since it's not visible, right? So the question is Sandeep, right? Sandeep has asked, how should we handle central session management and do central authentication authorization for multiple micro front-end integrations? So I'll just take a stab on it. Nilesh, you can just add on the top of it. So for the authentication part, right? Usually there are, if you're using the same framework, right? For example, if you're using React.js for all your 3 micro frontends, right? So nothing changes. It's not the way you used to handle it as a monolith, right? Like the passing of or storing of the context of the passing it as a tokens, right? So that stays as it is, right? Token validation would happen on every call, right? So that happens. It would be challenging if you have a split of different frameworks, like you're using Angular here, you're using Vue.js on the other side. So it will depend on your, you'll have to depend on the browser storage of that point of time. Yeah.
I think there are many interesting questions. Let's try to discuss this at the end, because I do have a challenges slide. I'll try to answer those in that slides. Yeah, let's go through the implementation. So as we discussed, I have 4 repositories. One is main repository for my shopping app, and I have the other 3 micro frontends for cart, for dashboard, and for sign up. So I have opened it in my VS Code, and I'm just running it in different 4 consoles. Let's go through each of them. So this one is my dashboard. I'll just refresh it. I can just click on it, and basically I can go through different products and add it to the cart. Then my cart, where I can just order something, and it will give me the ordering details, and I can just order this content. Third one is login, for where I can just put in some random details. If I can also register here and sign in. So at the end, my shopping application basically combines all these 3 micro frontends. I can just go to my cart where I have already added some product, but since cart can't be accessed without login, it is redirected to the login page. I'll just put my random username here and I'll just sign in. So I can see my cart and I can just order the things. So yeah, so this is the integration of different micro frontends. Now let's see how it works behind the scene. So if I just refresh my home page, I can see it's loading lots of JavaScript files. I'll try to focus on these 3 files. So if you see, it's loading a remote entry file from 3001, which was, I think, our dashboard wala micro frontend. And second one is 3003. It is for cart, and this is
for this.
Okay. Can you see it now?
Yeah, it should be better, I believe.
Yeah, so you can see these remote files are loaded from different servers. Now when I'll just clear it again, and when I click on my login button, it calls for login related micro frontends. So, and it basically loads it from here. So 3003. So that is the port we are running login wala micro frontend, and it loads the data from that micro frontend and it renders it. So this is how it works behind the scene. Now let's try to go through the code. When I started with this POC kind of application, I started with this React boilerplate. I had it in my personal repository. So it's nothing but a simple React with Webpack 5, and I can just go through these codes. Okay. So if you see, this is my product dashboard. This is a dashboard micro front end, and we'll go to some specific files. I had opened it in a commit view so that I can show you the exactly how we can simply convert any application into micro front end. So here,
Zoom in a bit.
Yeah.
Zoom in a bit.
Is it fine? Yeah. So in my Webpack file, I'm just changing file name to content hash. This is a general thing. Just this unique name I will need because our container application will be referring to different micro frontends or different JavaScript files that needs to identify which file belongs to which micro frontend. That's why we need to give a unique name here. And in the plugin section, I just have to import this Webpack Model Federation plugin. Since I'm running it on different servers, I have to allow CORS here. Then in the Model Federation plugin, I just define this is my dashboard micro frontend. Then this is my entry file, and this is the component for rendering part. So this basically is redirecting to the Bootstrap file. And these are some modules that I'm using in this micro frontend. And I want to share these modules with other micro frontends as well, so that I can just reduce the bundle size. Yeah. So, and for development purpose, I have just changed this ID to some unique IDs so that I can identify it in my Bootstrap file. Now let's go to the Bootstrap file. Nothing major in app.js. It's a normal app.js. This is a Bootstrap file that will be called on your mount basically. So we usually call this index file. I'm calling this Bootstrap file from this index file. You can notice this. I'm importing it like this. This basically tells Webpack you have to import it dynamically. And in my this Bootstrap file, I'm just I'm just rendering it into different elements. So if you see here, I have a condition which is identifying whether I'm running it locally. I'm checking the development mode and I'm checking if my index.html contains this unique identity. Then I'm just rendering it in a development mode. Otherwise, it's just exporting this mount function. Mount function is basically rendering your main application into the element. I have to wrap it in memory router since we will be rendering different micro frontend into the same application, right? So we have to share the routes. So the good way to share is using memory router. Your container application can use browser router, and these other applications can use a memory router for that. And that's that many changes only we need for any micro frontend to work. And or we can go to our shopping application, which will be our main container. So similar changes I have to do here, unique name. Then I have to import model federation, again cost thing. Then in model federation, now I have to tell model federation, these are the new micro frontends that I'm going to refer. And these are the URLs from where you have to fetch that. And again, the shared folder is same. I have to share these modules between different micro frontend. Let's go to the Bootstrap file for this. This Node.js. Okay, so in the Bootstrap file, where did I go? For the container application, we don't need to do much thing in Bootstrap file. I'm just calling Bootstrap, and we are just rendering it here in the Bootstrap file. So where it is, Bootstrap. Yeah. Here it is a bootstrap file. I'm just rendering it in an element. So now we have different routes for different micro frontend, right? I'll be loading this order component for cart micro frontend. So in that component, I have to import this. This was my micro frontend's name, and this was the component that I had exported from that micro frontend. Now I have imported this mount function, and I'm just mounting it on this reference. So this will render my cart or a micro frontend in this div basically. So this is all in nutshell. So we can try to change something in my one of my micro frontend, and let's see how it impacts. Let's go to the sign up micro frontend maybe, and let's change something in login form. So what I can change here is I can just make it, instead of signing, and can say login. I'll just save it, and now let's see how it is changing here. So now if you see, it's immediately reflecting login as button. So I can just refresh it, and again it will show the same thing. That is my login. In both the cases, so this is my individual micro frontend, which is reflecting the same thing. This is the integrated one. It's reflecting the changes. Now, how this will work in terms of pipelines. Now we have changed it. Let's try to commit it, and we'll see how it works. Okay, it's pushed. Let's see it in a Git repo. So I have these. Okay, so this was shopping app, and this is my product. Then this is my sign up application. So I had pushed it, and let's see how it's working in my pipeline. I had configured Git actions for this pipeline. If you see, this commit is triggered, and it's running, going through the pipelines. So you can see it's running different stages. So what it is doing, basically it will fetch the repository, then do npm install, build it, and push it to the AWS S3 that I have, and then invalidate my CloudFront previous cache. Then by the time this is running, we can check if it is impacting any other micro frontend. So let's open this product cart, and let's go to the actions. And I see there is nothing impacted here. There is no change in the actions part. No, this pipeline is not running at all. Only this login part is changed, and it's running in the pipeline. So we don't have to worry about other micro frontends. So those will remain still remain the same. We just have to push it to one micro frontend, and it will be impacted in production. So yeah, this is it. I think all the jobs are completed. Now let's see if it is reflected there. So this was my older application. If you see, it was signing. Let's see. Just trying to refresh the page. Yeah, if you see, it's changed, and now it is login page. So this is in my AWS S3 account, and we can check it here. So I have these 4 buckets here, and in each bucket contains a different micro frontend. And same, I have configured a CloudFront URL for that. So this is it about the codes. You can refer to this repo like Nilesh-Thorpe. You can find all the code here and refer this code. Now let's go back to our slides. And yeah, now that we have seen this in working, so this looks very simple, right? And it's a good thing to have. Then why not everyone is doing this, right? Everyone would like to do it, but there are different challenges. So let's see those challenges. So first one is styling challenge. So whenever any application is combined, at the time the styles get also combined, right? So you can have same name for different classes. You can have global styles. So that can impact your styling part. So that can basically break your UI. And how we can deal with that. So there are different approaches to deal with it. Like we can use BEM, block element modifier, where you basically rename the class or name the classes in a better organized way, so that it won't collapse with other classes. Then we can use different CSS preprocessors for that. Then we can use CSS in JS libraries. Like we can use styled components that will basically allow you to scope the CSS to particular component. There are different frameworks as well, like Angular. It has inbuilt feature of scoping the CSS to particular component. It doesn't collapse it other things. Then what is the next challenge? So next challenge. Okay. I went too ahead. So next is visual inconsistency across microfrontends. So if you have multiple teams working on a single application and those are working independently, their imagination will vary, right? And they will try to build their components as per their imagination, and they will have different perspectives. So that will eventually result in different UI, like someone might use black theme component or different kind of styling. So that will result in a bad user experience, right? So that will result in a visual inconsistency across your applications. So how we can handle it? So one easy and good way is to have a common shared component library. So we can build a common shared component library, and that we can use across different micro front ends, and so that the visual inconsistency can be eliminated with that. And third one is cross application communication. So though these are different micro front ends, but there will be I don't think that in practically there will be a very isolated micro front end. We do have to communicate with other micro front ends, like in terms of our login or cart, right? For cart to work, the user has to be logged in. So that communication we have to do. So how we can handle that? So that is a challenge. So there are different ways to it. Like you can use a different built-in events or custom events in the browser. So that can be used for communication across different micro frontends. Then you can use React's methodology of passing callbacks and data from top to bottom. So your container application can hold different callbacks, or basically that will handle the responsibility of communicating between different micro frontends. Yeah, so these are the two ways I can think of we can communicate between different micro frontends. Now, fourth one is application bundle size. So since we will be having different micro frontends, those can use different libraries, those can even use different frameworks. So it will eventually grow in size, right? The bundle will grow and it will cost to the user. The load time of your application will be higher. The bundle will take a lot of time to load. So how we can handle that? So one approach that we saw in my code itself, that we can just simply share some node modules. So that is kind of trade-off we have to do. Like we have to come to an agreement. We will use this particular versions of libraries across different micro frontend, so that it will reduce in bundle size. And there are other traditional approaches as well, like we use for any normal application, chunking, then other optimization technique. So those can be used in these situations. Yeah. Next is operational and governance complexity. So we have different teams, we have different micro frontends, we will have different repositories, even we will have different build pipelines. So this will introduce too many new things, right? We will have different new things to manage. So it will eventually become inevitable, right? So this will be a challenge basically, and this is the I feel a major challenge in terms of micro frontend. And that's why not every team or every project should be migrated to the micro front end. It depends on how big your application is, and then only we should go for a micro front end. And this is a kind of trade-off that we do when we move to the micro front end. Yeah, that's about organizational and governance complexity. Now, I think that's all I had in a slide. Thank you for your patience and bearing with me. And let's now go through the questions. I think there are too many questions. Okay, I think Nikesh had already answered some of them. Okay, maybe audience can ask the questions now. You can unmute yourself.
I think we can keep it open. I think there would be folks who have might have done MFE before and they want to share their experiences or something like that. That's also fine.
Can you show that Webpack feature? How so there is container app and there is micro front end application.
Mm-hmm.
Can you once again show the configuration?
Yeah. Okay, sure. So, okay, I'll show you it in VS Code only. No need to go to Git diff. So if you see my container application, this is my container application, and in Webpack, I have this dev wala configuration, even production configuration. I will show that one only. So if you go to the model federation, so here we are just naming this micro front end. Even container is a kind of micro front end only. That is just referring to other micro front ends. And we define different remote micro front ends in the remote tab. So we can have a dashboard, cart, and these three micro front ends. And this is the domain that is going to be referred when loading this micro front end. Now we have to share these modules. I had used React DOM, React Router DOM, style components, and these are my common components used across different micro front ends. And yeah, this is basically the configuration.
Okay. And how are the CSS styles loaded from the micro front ends?
It's kind of same bundling that we do for other normal Webpack application. We build different vendor JSS and other things, right? It's the same thing. Just that here we get liberty of referring it from different domain or different folders from dynamically, basically, because of this.
So, sorry, let me see if I can add more to the question. So here we know we are loading these JavaScript files, but those JavaScript files will also need their own CSS. Right. So where is the configuration to load those CSS? If in some micro front end, there is one CSS file that we need to include into our container.
Okay, yeah. So if you see, I have used this minify CSS wala file, and usually our Webpack, what it does, it goes through our index.html, index.js, right? And it's the index.js, and in app, I'm just loading my CSS file. So that is referring to different. So here I have this CSS file. My components can have different CSS files. So yeah, this can be my style component. So those are bundled inside this.
Okay.
So in your config, the CSS is within JS, like how Webpack used to do a long time back.
Yeah.
Okay.
There's no separate CSS file. It's a CSS in JS. Okay.
And yeah. What if you wanted to have separate CSS bundles for different micro front ends?
So yeah, that is also possible. I had used this as CSS, so I had used barely anything in that. It's like I'm referring to Andy, right? So it's importing from this file, and which is referred in my this app.js. So if I don't have it, then it won't load it. Let me try that as well. So this is my shopping app. Okay, no, let's not change it here, because shopping ad contains CSS for everything. I'm not sure how it will reflect. Let's try changing it in the cart. Now this is sign in, this is order. So if you see, it has become a plain application. Now, since my style components I had shared these libraries, right, and the style components. If I go to my main application, I can still see those CSS applied because those are shared CSS modules. I can, okay, so this is 301, sorry. Yeah, this one. Yeah, if you can see, I can still see the applied CSS here, since that is a shared module. Are you getting the point? Like, even though it's referred in this micro front end, since I had shared it, whatever the classes I had applied here, that will be reflected here. That styles will be loaded individually.
Right. Like even if any one of the micro front end loads it, the styles will be globally there. But I think I think even Omkar and I were trying to understand if individual micro front ends had their own styles and we wanted to ship them as separate modules, sorry, not modules, separate bundles. Then what would you do? Would you follow the same approach like how you did with the JS files or something different there?
Yeah, so technically, I mean, it's the same way traditional approach. We just have to be careful in terms of writing the classes in that case. So it should not be overlapping with each other, right? So like this is the case where I already imported this CSS file and the classes are already used in these components. So that's how it's getting applied, right? So if you had a plain CSS file in any component, we have to make sure the class names or the styles are not globally affected. You can use like I said, BEM model, where it will be more organized and you have to just that will get applied to the specific component. It will not impact other micro front end. So that we have to take care.
Got it. And I assume that Webpack, module federation will have some functionality to import those CSS files as well, like it has for Java, importing the JavaScript files. I'm assuming.
Yeah.
Can you also show the config of another micro front end?
Okay, yeah. So let's see this config. So here again, in the config, nothing major. We are just telling this is my cart application and this is my entry file. Then again, I am exposing this component, which is a bootstrap file. That's it. I can expose multiple components as well. So that is also possible here. And same thing, sharing the modules are there.
Okay, got it. Also,
I guess one way to solve the CSS problem is like with module federation now. So in the container application, you can define what are my remotes. So right now my remotes are just the JavaScript files that we are targeting here, like whatever index.js is exposing from each micro frontend. In the similar way, my feeling is the remotes, with the help of remotes, you can define where to find that CSS from for a micro frontend. And when you are actually rendering that micro frontend component, you can say, okay, import that micro frontend maybe from a remote URL that my Webpack module federation will automatically fetch for me. That is one way I can think of.
Yeah, that is possible, but I don't think that will solve your problem, right? Let's say you define a CSS here that is getting imported from different micro frontend, and that is loaded in your browser, right? Once it is loaded, that will get applied to anyhow, unless you are using it in CSS in JS, right? So that if you are using similar class name or similar component or similar element, then that will automatically get applied to that particular component. So
but that is true just for libraries. That is just true just for libraries. So for example, if you are following Bootstrap in each of the micro frontend, once it is loaded, it will get applied to all the micro frontend. But it is not true for the CSS classes that is very specific to one micro frontend. So if the CSS, so right now, I think in the example that you have, you are actually putting this whole Java CSS also in the JS bundle itself. So that is why it is actually applying those styles there, or it is actually being rendered in the container application also. That is why it is applied. If you actually define a separate CSS file in the micro frontend, somehow your container needs to load that also. Otherwise, your styles will not get applied. It is just the library styles which will get applied. Otherwise, not.
Yeah, right. So agreed. So whenever if you define some custom CSS or custom classes and you import it in that particular micro frontend, that will be applied only to that micro frontend only. Yeah, that is happening with this implementation as well. So yeah, I mean, since I have used library only, so that's how it's impacting everything. But if you had used custom CSS classes, it would have worked the same thing for this micro frontend as well.
Correct.
Yeah.
Kiran has raised his hand. Kiran, you have anything?
Yeah, hi Nikesh. So one question. So first of all, thank you very much for a nice demo on the talk. So in the application, you have the login page, right? So that I assume it as one micro app. And how are you handling the authorization or authentication among the different micro apps in the application? Okay. Let's say you have the shopping cart, we make an API call, which needs some kind of authorization token or something. How are you the communication between the main app and the micro apps?
So in my example, that demo I have given, right? It's not actually authenticated in the thing. It's something dummy that I have done. But to answer your question, so there could be different ways, like Nikesh rightly pointed in the middle. We can use browser things like cookies or browser sessions. So that can be used and accessed across different micro frontends, right? And that can be handled for accessing, or that can be used for accessing different APIs, right? So authentication can be a single thing. It can basically, a user can be authenticated through authentication micro frontend, and the different tokens, right, that we can store in the browser cookies or somewhere else, and that can be accessed in other micro frontends and used. And again, we can, if we don't have to go with that, then we can have other approach, like we can have a container application which is handling everything. So that is basically controlling the data. So once my authentication is done, the token will be stored in my container application, and that will provide it to the other micro frontend. So that can be other approach.
Yeah, I was just wondering.
I answered the question.
Yeah, like you mentioned, like the sharing the token in browser sessions. I was just wondering in terms of security, right? If it is a good practice to store them.
So usually, in my previous project, right, where we had to introduce or break down this monolith into a micro frontend, we actually picked up login as one of the modules. Since this application, right, this application is controlled by you, right? Although it's a micro frontend, but the security common module, right, can be imported by everyone. So periodical check, right, of the token, if it's there or not, and then you have to. So a lot of applications have this, right? Like if your page gets expired, you have to navigate to the login page, right? So you can use this common container approach, or you can have this module, right, which, as I said, like periodically checking the token. But token, consider this micro frontend is split up of your monolith. Like for the end user or the browser, right, it's still a single app, but it's only the deployment that we are doing, right? That is only the difference. Like everything that is controlled by your organization only. So token is being used or accessed by your app only.
Okay. I'll have another question. So you pointed out like a couple of integrations, right? Like the JavaScript based or a web components based integration, and module federation is one among them. So yeah, I'm just curious to know like what in ThoughtWorks. I am also an ex-ThoughtWorker, so just curious to understand like what has been followed across like multiple projects there. Is all the approaches been tried out, or what has been currently working out?
So micro frontends is like, it's still what do you call, an emerging topic. It's not like, and its use case is not applied for everyone, right? Like for not all projects would really need it. Like you'll have a very small application.
I meant like.
But I get your question. Yeah. So what do we usually use, right? Like it might differ from other projects, right? But the Webpack approach, right? The model federation, that is what we did before. But different projects, like for example, the current one, right? We are still like, this is just a spike that we did, and based on that we are presenting. So hopefully maybe in the next 2 or 3 months we'll actually finalize how we proceed further. So each has its own pros and cons. So for the current one we haven't finalized, but for the previous one, from my experience, it was the Webpack.
Okay. Yeah, because even in our team we are trying out micro frontends, and we because the Webpack 5 was not available on production yet, so we also thought of server side includes, but later moved on to the web component way, and it's pretty much helping us at the moment.
Cool. Nice to hear.
So to add to it, it actually depends on your requirement as well, right? In my experience, we already had a built application. So it was a legacy application. So we went for a build time integration where we moved one by one, and we used Lerna over there and tried to segregate different applications. So that helped us because it was incremental in that case. Yeah.
Okay. Any more questions?
All right. Thank you, folks. Thanks. It was great having all of you. Great discussions.
Thanks, everyone. I'll drop a feedback form. Just give me 1 second. Yes, do fill in the feedback for us. And yes, thank you for joining.
Thanks, Tanmay.